Okay, we're going to talk about different parts of quadratics today. There are a few different things that I want you to find. X-intercepts, Y-intercepts, the domain, the range, the vertex, and the axis of symmetry. So to make this a little bit easier on ourselves, I'm going to just draw a basic graph and show you what each of the things are. So here's a basic graph of a quadratic. My x-intercepts are where it connects to the x-line, and on these, the y is always 0. We know that, so it doesn't matter what form it's in. Whatever form it's in, if I'm trying to find the x-intercepts, I just make y 0 to find it, okay? If it's in standard form, which is ax squared plus bx plus c, you've done this a lot of times. To find the x-intercepts, you use the quadratic formula. And it's going to give you 2 x-intercepts. The only time that it won't give you 2 x-intercepts is when your x-intercept is the vertex. So every once in a while, it will just give you one number, which means that this is going to be 0. So you're going to go negative b plus 0, negative b minus 0, which gives you the same number. That's because the vertex is the x-intercept, so it only hits the x-axis once. Every once in a while, you will have one without an x-intercept, and that's because it's like this. It's above the x-line, and it's continuing infinity up, so it's never going to cross the x-axis, which is why you have a negative value down here, okay? So if a negative value happens here, that's why you're getting imaginary values. You guys dealt with that in algebra too, so we're not going to worry about that too much. Your y-intercept is right here. It's where it connects to the y-axis, and at that, x is always going to be 0. Your vertex is right here. It's either the highest or the lowest point. On this one, it's the lowest point. If you had a negative a value and your quadratic was facing this way, it would be the highest point. So this is your vertex. And your vertex is a point. So we're going to have an x and a y here. Your axis of symmetry always goes through the vertex. So your axis of symmetry is where the quadratic is the same on this side and on this side. And it doesn't matter if you have a positive a value or a negative a value, your axis of symmetry is always going to go through the vertex. So because it's an equation of a line, we have to write it as x equals some number. And that number is going to be the point from the vertex. Now, how do we find the vertex? We find the vertex by doing negative b over 2a, and then negative b squared. Whatever you get when you square b, you have to make it negative here, over 4a, and that's plus c. So that's how you can find it when it's in standard form. When it's in vertex form, it's obvious, but when it's in standard form, we do this. So your axis of symmetry is always going to be x equals negative b over 2a. The domain should always be from negative infinity to positive infinity, because this has arrows. So it's going from negative infinity to positive infinity every single time. Your range, and we talked about this in second period, your range is going to be from, if you have a positive a value, from negative b squared over 4a plus c to infinity. Oh, and this is going to be included. If you have a negative a value, it's going to be from negative infinity to negative b squared. over 4a plus c. Oh, sorry, this is included. And the reason for that is, see, this one's pointing down, so it goes to negative infinity, but it stops at the vertex. Okay? So, let's do some easy ones and then some hard ones. Easy ones are in vertex form already. This is in vertex form. I know that this moves 3 to the right and 4 up. So that means that my vertex is at 3, 4. Because that's my vertex, my axis of symmetry is going to be x equals 3. My domain is going to be from negative infinity to positive infinity. And my range is going to be from this up. So it's going to be 4 to infinity. I know it goes from this up because I have a positive a value. So x-intercepts and y-intercepts. On these ones, I actually have to plug it in. So my y-intercept is 2, 0 minus 3 squared plus 4. 0 minus 3 is negative 3. Negative 3 squared is 9. 2 times 9 is 18. 18 plus 4 is 22. So my y-intercept is 0, 22. I'll put it up here. For my x-intercept, I have to plug in 0 for y. So 0 equals 2x minus 3 squared plus 4. Remember, our order of operations is gemma. When I'm trying to solve for a variable, I go backwards, so I'm going to do a meg. So I'm going to get rid of the addition, subtract 4. I'm going to get rid of the multiplication, divide by 2. Oops. Get rid of the exponent, so I'm going to do a square root. And then I got rid of the grouping symbol, so then I just add over the 3. So always do a plus or minus here. So that gives me 2 values. Which what this means when this is negative is that I don't have any x-intercepts. So I'm going to put an empty set there. There's no x-intercepts. Harder ones, I think, are when it's in this form. Standard form. So this one, the easiest thing to find is the y-intercept. So I'm going to do that first. Zero squared is 0. 6 times 0 is 0. 2 times 0 is 0. 0 minus 0 is 0. 0 plus 1 is 1. So what that means is the y-intercept is just your c value when it's in standard form. X-intercepts, I'm going to set y equal to 0. Actually, I'm going to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Of course, I had to pick one that didn't have integers as the answer. I would simplify this to be, what is that, 4 times 6? So I'm going to simplify it to be, whoops. That is not 4 times 6, 4 times 7. all three of these are divisible by 2, so I can simplify it to be... So these are my x-intercepts, which means y is 0. And I'm listing both of them like this. So one is the one with the plus, one is the one with the minus. Y-intercept, x-intercept. I'm gonna find the vertex. Vertex is negative, I'm gonna use another paper so we can still look at this. Negative b over 2a negative b squared over 4 times a plus c. Negative 36 over 8, negative 18 over 4, negative 9 over 2 plus 1. Turn this into a fraction over 2. So negative 7 over 2. That's my y-intercept. Sorry, this is part of my vertex. Come on, Lothamer. This is part of my vertex. The other part of my vertex was 3 over 2. So my vertex is going to be 3 over 2, negative 7 over 2. Which means my axis of symmetry is x equals 3 over 2. My domain, negative infinity to infinity. And my range, a is still a positive value, so it's going to be negative infinity to negative 7 over 2. And that's all we're doing today.